Good day, ladies and gentlemen. You're welcome to Apex Easy Learning online lecture where you'll be taught various subjects: physics, chemistry, maths, biology, and other arts and commercial subjects. My name is Pisa. In these sections, we'll be looking at physics. Optics is the branch of the physics we'll be looking at. And the topic is wave. Wave. First of all, let's look at what wave is. A wave is a disturbance which travels through a medium and transferring energy from one point to another without permanent displacement of the medium. A disturbance that travels through a medium, transferring energy from one point to another without permanent displacement of the medium. For instance, a very common example: when you throw stone into a pool of water, you will discover that there will be some pattern like this drawn on the surface of the water, and these lines will spread out until you are no longer observing that particular lines again on the surface of the water. That line is what we refer to as waves. So we said a wave is a disturbance which travels through a medium. Here the water is a medium, and transferring energy. That lines, the circular lines you are seeing, are the energy transferred from one point to another, but without any permanent displacement of the medium. We have wave motion, which involve transferring a disturbance from one point to another in a medium without transferring of particles of the medium. That is what we call the wave motion. First of all, we'll be looking at types of waves. Types of wave. This one is in terms of material medium. First, we have mechanical wave. Mechanical wave are waves that require a material medium for their propagation. The ones that required a material medium. We have water wave, sound wave, sound in a string, and the rest. So all these things are the one we refer to as wave. So when you look at that, all the water wave, sound wave, wave in the string, you will discover that all of them required material. Before you can produce a water wave, you need water, and probably you need a stone that you can throw in it. If it is sound wave, you need to produce a sound using either drum skin or anything that can produce sound. Even a table, eating a table will give you a sound, and that sound, when you look at it, the table and you that beats the table, these are the things it required material. So that is material. So that is why we call it mechanical wave, because it required material. And we also have electromagnetic waves. Electromagnetic waves are waves that do not require a material medium for their propagation. This one, there is no need for material medium for the propagation. Example is the light waves. We have radio waves, we have x-rays, and so on and so forth. So these do not require material medium for their propagation. Another things we are going to look at is the types of waves based on the movement. The movement. We have transverse waves. The transverse wave are waves that travels perpendicular to the medium of propagation. The wave that travels perpendicular to the medium of propagation. This is the graph to shows a transverse waves. You look at it, it travel perpendicular to the medium of propagation. As you can see it, as it's moving, the particles is the one you see as red. It's moving, it's moving. So this type of waves is what we refer to as transverse wave. And we also have longitudinal wave. These ones are waves that travel parallel to the medium of propagation. Example of that, we have sound wave, we have wave produced by tuning fork, we have wave produced by drum skin, and this is the diagram to shows a longitudinal wave. When you look at it, it travels parallel to the medium of propagation. Now let's look at the general graph for wave, the transverse waves. Now when you look at it, we have some parameters that we must look at. The parameters that we must first of all observe before we can go into major work there. One there is this. First thing, we have crest. If you look at it, the crest from this place, crest is the upward displacement of the wave. The upward displacement of the wave. When you look at it, the upward displacement of the wave, when you look at it, this is up. So this is the crest. So this part is crest. You can look at all of them. They are the one we call the crest. While we have the trough. The trough are the downward displacement. The downward displacement, we look at this. This is downward. This is another one. Downward, downward. So they are the one we refer to as trough. So we have crest and also we have trough. Another thing is the amplitude. If you look at the diagram, the amplitude is the maximum displacement of the wave. The maximum displacement of the wave. You look at it, that highest point there. From that place is the total amplitude. So the amplitude is the maximum displacement of the wave. And also we have the wavelength. It's represented with that sign lambda. Is the distance between two successive crests or trough. So when you look at this diagram, you can see where wavelength is. The distance between the two successive crests. You look at it, this point to this point, or from this point to this point, or you can say the trough, the two successive trough or two successive crests. That is what we refer to as the one single wavelength. And another thing there is the period. The period is the time taken by a wave to complete one oscillation. Time taken by wave to complete one oscillation. That is what we refer to as the period. Then we have frequency. The frequency F is the number of complete oscillations or cycle made in 1 second. So it's given as 1 over t. That is 1 over period. That is the number of complete oscillations made in 1 second. That is what we refer to as wavelength. And also we have wave speed. Wave speed, which is when you talk about the speed, what is the speed? Speed is the distance covered in a specific time. So when we relate it to wave, the wave speed is the distance which the wave travels with time. The distance which wave travel with time, meaning wave speed is going to be the wave distance all over time. That is the distance covered by the wave over time. Here the distance between the two successive crests is one wavelength. So meaning if you are looking, we are dealing with this, we can say the wave speed is wavelength all over time. So if you look at it, wavelength over time, meaning that we can have it as lambda over t. Lambda over t. So if we have it as lambda over t, what do we have? Meaning we can separate it if we say the wave speed, which is v, is equals to wavelength over t. We can separate this and say v equals to wavelength times 1 over t. And don't forget, if you recall, we said f, which is the frequency, is 1 over t. So from here we can substitute for f. So if we substitute for f, we'll be having v to be equals to lambda times f, which is f lambda. So f lambda is the wave speed, and that is why you have it here as we have v equals to f lambda. So that is the wave speed. So let's look at some little calculations. Let's look at these few calculations. We'll be looking at them one by one. The first questions here: calculate the wavelength period of a radio signal of frequency 3 times 10 raised to power 5 as if the speed of the wave is 3 times 10 raised to power 8 meter per second. Let's look at this. Here we are given the frequency as 3 times 10 raised to power 5 and the wave speed as 3 times 10 raised to power of 8. Let's look at it. Here the frequency, we said the frequency is the f is equals to 3 times 10 raised to power of 5, and we said the wave speed is 3 times 10 raised to power of 8. And don't forget, we are asked to calculate what? The wavelength and the period. So let's see it. We said, if you recall, that v is equal to f lambda. So they asked us to find the wavelength, which is this lambda. So we can easily find the wavelength, which is the lambda. So very easily. So wavelength, which is lambda, will be equals to, if you make the wavelength the subject of formula, it will be v over f. So from here, what is v? V will be equals to 3 times 10 raised to power of 8 divided by 3 times 10 raised to power of 5. So let's punch our calculator. What is that? That will give us lambda equals to 1000 meter. That is lambda. But don't forget, you are asked to calculate two things. The next one, we have to calculate the period. So let's look at what period will be. So you will recall that we said that v is equals to lambda over t. That is, the t there is the period. Now if you make the t the subject of formula, the t will be equals to lambda over v. So what is the lambda? Lambda here we have it as 1000 all over the v. The v is 3 times 10 raised to power of 8. So meaning the t will be equals to, when you punch your calculator, what would that give us? That will give us 3.33 times 10 raised to power minus 3. 3.33 times 10 raised to power minus 3, or simply 0.0033 seconds. So here we will have seconds there. So that is the time, the period. Now let's look at the second question. The second question. Here we are asked if a light wave has a wavelength of 500 millimeter in air, what is the frequency of the wave? This one is jump questions. If you look at it, it's past question. Here we are to find the frequency. We're given the wavelength and we're given the wave speed. So the wavelength and the wave speed, if you look at it there, we have the wavelength. The wavelength is 500 millimeter. If you convert it to meter by multiply by 10 raised to the power minus 3 or divide by 1000, we'll be having the wavelength to be 0.5 meter. 0.5 meter. And we're given the wave speed to be 3 times 10 raised to the power of 8 meter per second. So they ask us to find the frequency. So the frequency, if you remember that we have V equals to F lambda. If you make F the subject of formula, F is going to be equals to V over lambda. And what is that? Meaning F will be equals to V is what? 3 times 10 raised to the power of 8 all over the lambda is 0.5. If you punch your calculator there, what are we going to have? So it will give us 6 times 10 raised to the power of 6 times 10 raised to the power of 8 as 6 times 10 raised to the power of 8 as. So that is that. Another question there is this. Here we have this diagram. It's also past questions jam. Here we have the diagram. They said the diagram above represents a transverse electromagnetic wave traveling with speed of 3 times 10 raised to the power 8 meter per second. What is the frequency of the wave? We are looking for the frequency and we are given the wavelength and the wave speed. Now, but when you look at it, this diagram shows 3 movements, that is 3. So if we are calculating for this one, the wavelength to total wavelength here is 0.3. So we are interested in one cycle. We're interested in one cycle. So what is going to be the wavelength if the total cycle here, if we have 0.3, so one cycle is going to be 0.3 divided by 3. So we'll be having this. So meaning our wavelength is going to give us, the wavelength will be 0.3 divided by 3, which is going to be 0.1 meter. So we'll be having it as 0.1 meter. And don't forget that we are also given the wave speed V as 3 times 10 raised to the power of 8 meter per second. So they ask us to find the frequency. So very simple. Don't forget we have V equals to F lambda. So meaning our F, which is equals to V over lambda. So we'll be having F to be equals to V 3 times 10 raised to the power of 8 divided by the lambda, which is what? 0.1. So in that case our F is going to be equals to what? 3 times 10 raised to the power of 9 as. So that is that. That is very, very simple. So these are the little simple calculations we can solve for now. So we are going to give you this little work to do, so you can also solve these questions on your own. It's very simple. If you have any difficulty, you can contact us. You can send us a message, or you can send us comments. You can put the comments under those the video. So please try to reach us in case you have any difficulty. Next class will be continue with the progressive and standing wave. Once again, I'm Peace. Thanks for watching.